Okay, and then now let's proceed na dun sa pinaka-heart no nung course na ito no. Ito po yung important, very very important na part ng ating course no, which is about the architecture of ORAN itself. No? Okay, so we already know that radio access network or RAN is here no, ito pong color red no. This access network is the one connecting our end user or the user equipment no, to the telco system no, via radio frequency. No. So the access network or the radio access network connects to the core network via the transport network or also known as the backhaul. No. Yeah. Okay, so ano po yung main RAN components? No? Pag tinignan po natin yung loob nitong access network, no? Ito po yung main components natin, no? The baseband unit and the remote radio unit. No? And earlier we already show no, that nung naghiwalay itong dalawang to, na-introduce yung ating front haul na interface. No? So may backhaul tayo sa likod, yung papunta sa core, yung front haul naman, yung papunta sa remote radio unit. No? Yan. Okay, so napakita din to no in the previous course yung parang different interfaces and different components no. This is one way of viewing it no. So we have the core network involving various na high performance devices, and this is not covered no, in our course since ang main focus talaga natin is the RAN no. This part nearer the user equipment no. Okay, so the core network connects to the RAN via the backhaul. And then inside the RAN would be different components, no? Yung dalawa would be the remote radio unit and the baseband unit. And in the course, you'll also learn, no, ano po yung pinaka-functions ng remote radio unit, no? Like, ano yung naka-assign sa kanya, no? Is it focus on analog to digital conversion or digital to analog conversion, mga physical layer protocols, and so on. Okay, and then we already know that RRU and BBU are connected via front haul. And then later, nagkaroon din po ng parang disaggregation si BBU. So medyo marami kasing parang functions, protocol pa si BBU. So pwedeng paghiwalayin siya further into DU and CU or distributed unit and centralized unit. Yan. Tapos nagkaroon ng mid-haul. No? So tatlo ng interface, no? Yung main interface, front haul, mid-haul, and back haul. No? Connecting yung RRU, DU, CU, and the core network. No? Yan. So bakit pinag-iwa-hiwalay? Kasi later maaaral po natin no, yung tinatawag na functional split. Pwedeng piliin ng mobile network operators no, kung anong mga functions yung ilalagay sa bawat component para maging mas flexible no, yung sa deployment scenario nila. Depende kasi kung ano po yung needs no. Maybe on the particular service area, hindi nila kayang ilagay yung buong RAN, so they can just put in the remote radio unit near the service area, and then the DU/CU maybe just in their central office no. O kaya naman kapag small cells, usually sama-sama na yan no. Like yung mga in-building na small cells natin, lahat sila sama-sama na, then that means hindi na kailangan talaga ng pagkakahiwa-hiwalay. No? So mas flexible na no, yung ganitong setup. Hindi siya fixed na dapat sama-sama sila in one location or dapat sobrang laki ng device or something like that. No? Yeah, so ito po yung mga front haul no, or FH, MH, saka BH. Yan. So pagdating nung sa ORA, no, they introduced more components, no. Nagbago lang ng konti yung mga CU, DU, RU, no. Nagkaroon lang ng O sa harap, no. So ORAN centralized unit, ORAN distributed unit, ORAN radio unit, no, or remote radio unit, no. So ito po yung parang ano lang muna, overview of the architecture, no, para hindi po nakakabigla, no, kasi later makita niyo mas marami pang components, no. So in RU tsaka DU, di ba, ang nagko-connect sa kanila is FH, yung front haul. So in ORAN, nagkaroon lang ng prefix na O to mean it's now open front haul, no. Kasi in the discussion po in this course, may iba pang interfaces na front haul, and then some are not open, no. So dito ini-specify na dapat open yung front haul na gagamitin for ORAN architecture. And then ito po yung CU natin, no? And then it's composed of the control plane and user plane para po ma-separate yung parang processing ng mga overhead. Yung isa is focused dun sa data of the user, no? So ito po yung main, no, yung centralized unit natin. And then the mid-hall interface again, no, is connecting the CU and DU. This one, no, is what we call the F1 interface, no, defined by 3GPP. So ulitin ko po, no, ito po yung front hall, ito po yung mid-hall, no. Mid-hall is F1, no. Yun po yung name niya talaga. No? Mid-hall is the generic term, no. F1 is yung specific na interface, no. And then, connecting this CU papunta pa sa ating core network would be the backhaul, no? Pero pagdating kay ORAN architecture, nadagdagan itong mga to, no? Itong SMO and itong near real-time RIC, no? Anong purpose po nitong mga to is for optimization itong RAN, especially kapag sobrang dami na kasing components and they need to monitor, manage po yan lahat, no? And it's easier to manage if merong parang other components, no, to monitor their operations, no? Yan. So CSMO or System Management and Orchestration, this is responsible for the RAN domain management. And then inside it, meron pang tinatawag na non-real-time RIC, no? Okay, so madi-discuss po yan later and also ma-emphasize din siya doon sa next course, no, yung i-overview natin next week. Yan. So yung NRT or near real-time RIC, it supports tasks that require less than 1 second latency. So kung ano man yung mga task na requirement nitong RAN, para ma-optimize yung kanilang operations, like for example, yung mga pag-manage ng mga channels and so on, no? Anything that needs almost real-time na response, ito yung nagpo-process, no? This near real-time RAC can also connect to other nodes, no? Kasi ito, this is just one node, no? Parang one base station siya. Meron pa pong ibang base station, no? Ayan. Sige po, may question po ata, no? Maybe you can chat po, no? So that I can read po in a bit. No? Okay, and then, what else? Sige. Okay, so siguro we can go, no, dun sa parang architecture na, no? Ito po yung architecture without the interfaces, no? So nabanggit na earlier, no? Meron tayong CU, DU, RU. Humaba lang yung pangalan po nila kasi nagkaroon na ng ORAN sa harap, no? So still, RU and DU is connected by the front hall interface. Tapos yung centralized unit natin, napaghiwalay lang, naging control plane saka user plane para lang mapaghiwalay yung functions nila. No? And then this CU connects to the DU via the mid-hall interface. No? Yan. So ito pa rin naman yung tatlo kanina. No? Nadagdagan lang po talaga tayo ng other parts. No? May kulay na rin siya, no? Kasi this is also what the ORAN Alliance use, no? Para consistent po at mas madali natin maalala, no? Ayan. Okay, so may ORAN cloud infrastructure as well, not part of the ORAN itself or the RAN itself, no? But pwede kasing magkaroon pa ng mga cloud native virtualized functions dito. Yan. So ito na po yung pinaka-important na slide sa ating course. No? This is the ORAN architecture. No? Kaya hindi ko po siya agad pinakita immediately, no? Kasi maraming components and maraming interfaces dito. No? And actually, ito po isa sa mga assignment do sa course, no? To draw this architecture and then explain po yung bawat parts. No? So that mas ma-familiarize po siya, no? nung learners and also mas may retention, no, if we handwrite the content. No? Ayan, so simulan ulit natin sa RU. No? So RU, radio unit. Again po yung O here just specifies na nasa ORAN na architecture na kasi. No? RU and DU, distributed unit, is connected by the front hall interface. No? Dapat open front hall interface. Meron lang parang dalawang planes para paghiwalay lang yung parang yung M plane, management plane, saka itong control user and synchronization plane. No? But essentially, ito po yung front hall natin. No? Notice yung mga interfaces, may mga parang color, ano pa sila, no? May legend pa sila. Kasi yung mga gray dyan, those are defined by 3GPP. No? So ito po yung talagang architecture before ng RAN. But minodify siya ng ORAN, no? So that we can incorporate yung other functions pa, no? Other nodes natin na introduce, no? Okay, and then we know the DU is connected to the CU. And in this case, yung CU has two parts because of may set ano tayo dito, no? Control plane and user plane, no? So yung ating mid-hall interface is the F1, no? Dito may dalawang F1 lang, isa kasi control, isa naman user, no? Ayan. So, bale ito na yung run talaga, no? Yung CU, DU, RU. But as mentioned earlier, no, para mas ma-optimize yung operation niya, and syempre may mga virtualized network functions siya, no? Pwede kasing i-optimize yung mga yon, no? By understanding the whole network, no? Including other nodes, no? Gumagamit ng near real-time RIC, no? So, ito po yung mga different na ito yung mga different na task, pina-perform na task ng near real-time RC is anything almost real-time, less than 1 second, para po ma-optimize operation nito, no? Okay, and then notice no yung near real-time RIC has an interface called E2. E2 is the interface connecting to the RAN, no? So yung papunta sa CU, papunta sa DU din, no? So, ang nangyari is kinukuha niya yung mga data and then pina-process niya yon tapos it can send updates, no? Tapos itong mga virtualized functions to may updates sila from time to time, no? Para if, for example, maybe one of the virtualized functions goes down, then pwedeng mag-optimize for load balancing and so on, no? So dito na nagkakatalo-talo, no? Ano yung software, yung proprietary software that can help na optimize talaga, no? Pwede magkaroon na po dito ng AI, ng machine learning na aspect to optimize and maybe magkaroon din ng other na applications pa, no? Okay, and then ito, no? Remember E node B. Yan po ang base station, no? Para sa 4G. So, pwede rin pong kumonek yung ating near real-time RRC to other nodes, no? So, ito kasing tatlong ito or apat na yan, this is just one node, no? Parang one base station, no? Pwede pa sa iba pang base station. So, may iba pa dyan, no? Pwede mas marami pa, hindi lang dalawa to, no? So, you can connect as well, no? The near real-time RRC can also get data from other nodes, no? Via the E2 interface, no? Bale, itong part na to, no, yung ORAN eNode B, contains as well inside are the CU, DU, and RU. No? Ayan, so marami-raming interfaces po, no? So meron din as well E1. This is just the interface connecting the control plane and the user plane. And then meron po ditong X2 at saka NG na mas madidiscuss no kung cover po natin yung ibang slides, no? But these are the connections as well na to other nodes, no? Yan. Okay, and then what else, no? Yung near real-time RIC is yung real-time na late na task nga, no? Less than 1 second po yan. But meron po tayong non-real-time RIC, no? Ito po yung mga task na magre-require ng longer time para ma-complete. Okay, so yung the non-real-time RIC are tasks that require more than 1 second. For example, if you need to have traffic forecasting, no? Or parang user management, no? Or anything pa, no? Na magpe-predict or something else, no? Nandito po yung mga tasks na yon. So, nangyari is kukunin niyo yung data, no, or other important analytics pa, no, sa near real-time RIC via A1 interface. Yan. So, ito po yung mga interface na yan to show the connections and pakita, no, kung ano po yung mga may mga relationships dito, no. Yan. And then, ito po yung service management and orchestration. Mas marami pa siyang ginagawa, no. May mga connections din like O1 plane papunta sa other nodes, no? And then O2 plane papunta sa O cloud. Parang dito na po yung mga cloud na functions, no? and so on, no? Okay, so bale yung RAN natin before, no, ito pong part na 'to, no, yung color red saka orange, these are the components of the traditional na RAN and yung other, RANs natin. But when we go to ORAN, no, nagkaroon na po nung mga new interfaces and new components, no? Ang purpose nila is to optimize and also parang magamit further pa yung mga virtualized functions ng ating RAN, no? Para mas ma-improve yung mga performance, ma-improve yung traffic, ma-improve yung user experience, no? We go into other details pa about the architecture. Ayan, so ito parang another way, no, of looking at the architecture. This is what we call the ORAN Alliance Reference Architecture. Hindi pa nga siya yung complete na reference architecture kasi gusto ko muna mapakita sa inyo, no, yung how it is related dun sa kanina, no. So halos pareho lang siya, yung color coordination same, may SMO tayo, non-real-time RIC, near real-time RIC, connected by A1. Yung RIC natin, yung RIC natin connects to the CU and DU. So yung ating CU may contain multiple radio access technology, no, multi-RAT. So ito po, it just means, no, yung it's not just 5G, we can also have 4G or 3G, no. Originally, the ORAN system is focused sana on 5G, but eventually they were able to do something, no, even for 4G and 3G, no, para lahat po ng protocols or lahat ng generations magi open din, no. Yan. Okay, and then we have the distributed unit, no, connecting to the CU. So CU to DU is the mid-haul. Another name for the mid-haul interface is F1. This is specified, no, by our 3GPP, no. And then the front haul interface connects the DU and the RU, no. Yan, ito po yung pinaka ano na, no, yung detail na ng ating reference architecture. Inside the SMO, may mga design, inventory, policy, configuration, and so on, no. So medyo mas long term, no, yung kanyang operation, no. Then ito na yung ating near real-time RIC, mostly focusing on tasks na kailangan i-resolve agad, no, like radio management, mobility management, quality of service, interference, and so on, no. Possibly, no, yung mga data na nakuha nitong non-real-time RIC, pwedeng gamitin for creation of machine learning models, no. And then those machine learning models may be updated, no, sa ating near real-time RIC. Pwedeng itong mga trained model na to is coming from the non-real-time RIC. Tapos, yung model na yun i-apply, no, para po ma-optimize, no, and ma-manage yung ating mga DU and CU, no. Ayan. And then, ito po yung ating CU, no, na control plane and user plane, no, connected by E1. And then, itong mga to are protocols, no. Later po siya, no, if na makapag-enroll na kayo sa course, di-discuss din po yung mga protocols na yan, no. Yan, notice yung E2 connects the near real-time RIC, saka yung CU and ang DU, no. And then, F1 is the mid-haul interface, no. Tapos pansinin nyo yung ating mga CU are COTS, no, platform, no. And then DU is the one performing usually, no, these protocols, yung RLC, MAC, physical, higher physical layer. Much later po mas mako-cover po ito, no. But essentially, yung ating RAN, no, has different protocols that they need to perform para magawa po nila yung kanilang task, no. And due to the functional split, pwede pong mahiwa-hiwalay, no. Alin po dun yung ginagawa lang ng RU, alin lang ginagawa ng DU and yung CU. Depende po kasi dun sa parang use case ng mobile network operator. Ayan. So ito po yung isa pang assignment actually, no, kung kailangan yung learners, no, they draw this, no, at the start. Probably they don't understand a lot of the details, no, but eventually because they will draw them and try to understand each connection, no, mas ma-absorb po nila yung architecture this way. Yan. So bale ang important na part po dito sa course would be this slide, no, and then yung ORAN architecture earlier, no? Ito pong slide na ito, no? Showing the 3GPP nodes, 3GPP interface, ORAN interface na bago, yung mga color green, and yung mga ORAN nodes, no? Like yung RIC, saka SMO, no? So pag ORAN, basta may O sa harap po, no? Pag 3GPP pa lang, wala pa yan, no? Hindi pa nilagay yung O sa harap, no? Ibig sabihin, the nodes are not yet open, no? More likely, they follow the proprietary na version, no? Ayan. And then, siguro let me discuss, no, some of the working groups, no? Si ORAN Alliance include some working groups. No? They are in charge of yung pag-aaral ng mga different parts of the ORAN architecture. Like ito, working group 1, mga use cases and overall architecture. And then we have working group 2, they only focus on the non-real-time RIC tsaka A1 interface, no? So pag binalikan po natin yung reference architecture, yung A1 interface, or yung ating, architecture pala, no? A1 interface is this interface here, no? Connecting the two RICs. Ayan. So yung prepare ng mga specifications saka nung ating mga details on this, no, is from working group 2, no? Ito po yung kanilang focus, no? Working group 3 is more on near real-time RIC and E2 interfaces. Remember, E2 interfaces is yung interface connecting yung ating near real-time RIC papunta dun sa CU at saka DU. Ayan. So, ito po yung part na yon, no? So, near real-time RIC, yung E2 interface, papunta sa CU, saka sa DU, and as well as other nodes pa, no? Yung CU, DU po nung other nodes na yan. So, hindi lang siya nag-manage ng isang RAN, no? May iba pang RANs na pwede niya i-manage, no? And then other working groups, no, like ito, working group 4, open front hall, working group 5, other interfaces pa, like ito, mid hall, and so on, no. Okay, so, these are other working groups, but not much focus sa ORAN, no. May, ito is for orchestration, and so on pa. So yung important for this architecture would be this first 5 na working groups natin. No? Ayan. Okay, so siguro to summarize, no, let me use this slide, no, para ma-end po yung discussion, no. So originally, no, we know that we have BBU and RRU. Ito po yung split architecture nung ating traditional RAN na may front hall interface. No? So front hall interface, one of them is yung ating CPRI. No? Proprietary po yung tatlong yan. No? Kaya later nagkaroon ng ORAN para mas madali po magkaroon ng changes sa network, mas maging modify ng mobile network operator according sa use case. No? Baka doon sa particular service area, they can only accommodate RRU. No? And then eventually they have this 3GPP approach na specified in the technical report 38.801, wherein the BBU, yung baseband unit natin, na paghiwalay further yung functions niya into CU and DU. No? Yung centralized unit and distributed unit, no? They have a mid-haul interface here. No? Ayan. So this mid-haul interface is yung ating F1, no, interface, no. So ang maganda dito sa TR, no, yung technical report na to, yung mga functions nitong mga to may vary depending on ano yung split, no. Bale yung mga lahat ng mga applications or rather lahat ng mga functions nila, lahat ng mga protocols na kailangan i-perform nung RAN, pwede pong mapaghiwa-hiwalay yun, no? Depende na lang sa use case, no? Baka yung DU na hardware ng mobile network operator hindi kayang i-perform lahat, no? So maybe it will only perform a certain portion. Okay, so ito po yung isa sa mga critical na parang important information sa ORAN architecture, no? And makita nila, no, the reasoning behind having this one.